Hello everyone. This is a short tutorial to help you out with calculations in the week 2 discussion board. Uh, this week we will look at how to solve equations. So I have an equation solving procedure that I tend to go by. The first thing that I like to do is if I have any fractions, I would clear the fractions by multiplying both sides of my equation by the least common denominator. The second thing that I like to do is to clear parentheses if I have parentheses by using the distributive property. Next, I like to collect like terms on each side of the equation. For example, if I had 2x plus 3x on one side of the equation, I would go ahead and combine that to make 5x. Then I use the addition principle to move any variable terms to one side of the equation. So if I have variable terms, numbers with variables with them on each side of the equation, I want to use the addition principle to get those combined. And then if I have numerical terms on each side of the equal sign, I want to use the addition principle to get those combined to the opposite side. And last, I use the multiplication principle to solve for the given variable. So if you want to take a minute to pause the video to write those steps down, this will be the time to do that. Okay, so this week we're looking at the Cowlings Rule. It says the Cowlings Rule is a function or formula used to determine the child's dosage of a drug in comparison to an adult's dosage. The formula for this rule is lowercase d equals capital D times a plus 1, all divided by 24. Now it's important that you define your variables so we will know what they represent. So in this case, lowercase d represents the child's dosage. Capital D represents the adult's dosage. And lowercase a represents the child's age. So if we have any two pieces of information, then we can figure out the other piece of information. For example, if we were given the child's dosage and the adult's dosage, we can tell the age of the child that would be receiving that dosage. Okay, so let's use that formula and let's work through this problem. It says if a doctor prescribes 1,000 milligrams of acetaminophen for an adult, then how many milligrams would be prescribed for a 7-year-old child? So first of all, it tells us that capital D, the adult's dosage, is 1,000 milligrams. Then it asks us how much would the child's dosage be. So that's what we're looking for. Then it gives us the child's age of 7 years old. So let's take that information, plug it into our formula, the Cowlings Rule formula, and solve. So in this particular situation, we're given the adult's dosage of 1,000. We're given the child's age of 7. So we will substitute in 1,000 times 7 plus 1 all over 24. Now since d, the lowercase d, is already by itself on the left-hand side of the equal sign, then we don't have to move anything from one side to the other. All of our calculations are on that right-hand side. So now we just need to use our order of operations. And we want to simplify in our numerator to get that to be one number, and then divide whatever we end up with by 24. So using the order of operations, we would simplify what's in parentheses first. So 7 plus 1 is 8. Then after we add 7 plus 1, we would multiply 1,000 times 8 to get 8,000. And then last, we want to divide 8,000 divided by 24, which gives us about 333.33, and that repeats. So 333 repeating. So we would say that that child's dosage would be, at 7 years old, would be about 333 milligrams. Okay, so that's how you would work through that problem. Okay, our next situation says that if a doctor prescribes 200 milligrams of ibuprofen to a child, so that tells us that lowercase d is equal to 200 milligrams. When he would prescribe 600 milligrams to an adult, so capital D equals 600 milligrams, then how old is the child? Well, we're looking for the child's age in this case. So let's write our formula down again. We have lowercase d equals capital D times a plus 1 all over 24. So what we're going to do, we're going to take what's given, substitute into our equation, and then solve for a, for the child's age. So lowercase d was 200, capital D was 600, and we're dividing that by 24. Now I'm going to use the procedure that I demonstrated earlier. There are a couple of different ways you can go about this to solve this equation, but I like to stick to a process. So I'm going to first of all clear my fractions. The only denominator that I have is 24. So I'm going to multiply both sides by 24 in order to clear that denominator out. And you may want to make that 24 over 1. So now on the left hand side, 24 times 200 is 4800. On the right hand side, since I have this 24 in my denominator and that 24 in my numerator, they would cancel each other out. That's the whole reason I multiplied by 24. It's so I could clear my denominator. Now in this particular step, you could go ahead and divide both sides by 600 if you choose to, but I'm going to stick to the procedure that I presented earlier. So my next step would be to clear my parentheses by using my distributive property. So I'm going to clear my parentheses by using my distributive property. So I would multiply 600 times A, which is 600A, and then 600 times 1, which is 600. Now the next step on my checklist is to get all of my variable terms on one side of the equal sign. Well, the only place that I have a variable here is with 600A, so I'm good with that. The next thing that I need to do is to get my numerical terms on the opposite side. So I have 4800 here and I have 600 here without variables. So I want to move this 600 over to the left hand side to get it away from that variable term there. So since I have plus 600, I'm going to use the opposite operation. I'm going to subtract 600. Now in equations, whatever you do to one side of the equation, you must do to the other side of the equation in order to keep that equation balanced. Now the last thing that I'm going to do is to use my multiplication principle to isolate A. I want this to be 1A. So since I have 600 times A, I'm going to divide by 600. That's because any number divided by itself is 1. And that's my objective, is to make this into 1A. So I get 7 equals A. So the child in this case is 7 years old in this situation. Alright, I hope this video helped you out with working through the problems that you have to work through for the discussion board this week. Hang in there and continue to work hard. Thanks.